take each of the data, add them up, and divide by, in this case, we have 6 data, which is you add them up, divide by 6. You have, I think my number is wrong. I think is 30. Is the answer is right? The answer is 5, but this thing here is 30. It's not 60, ladies and gentlemen. Is 30. Okay. Yeah, 30 divided by 6 is 5. The answer is right, but the 60 is not. Okay. So sorry for the typo. Again, the first thing we need to do is we need to find a mean. The second step we need to do is we need to find a deviation. What is the deviation? Reminder, the deviation is the data minus the mean, right? The data, which is my data, is 2, 2, 3, 5, 9, 9. Those are my data. I need to take the data minus the mean, which is 2 minus 5 will give me -3, -3, -4, 0, 4, 4. And again, like I mentioned right here, if you take this -3, -3, -2, that will give you -8. And again, +8, they cancel out. Your deviation is equal to 0, right? There will be some data above and there will be some data below, right? Your deviation, just take the data minus the mean. What is your third step? Your third step is now we need to square the deviation. We need to take whatever your step 2 is and we'll square them up, which is again 3 times 3 or -3 times -3 is 9, -3 times -3 is 9, -4 times -4 is, 2, -2 times -2 is 4, and 4 times 4 is 16, and 4 times 4 is 16. That's your step 3, which is you take your deviation and you square them, square the deviation. Step 4, we need to sum the square of the deviation. Sum of the square of the deviation, which is you take the 9 plus 9 plus 4 plus 0 plus 16 plus 16 to give you 54. So right here at this step, ladies and gentlemen, at step 5 right here, because they ask us for the sample, because they ask us for a sample data, right? We have to divide by n minus 1. If they ask us for population, which is some of the question on your ALEKS, they ask you for population. Because they ask you for population, you need to just divide by n. Okay, so make sure on ALEKS, when do you divide by n and when do you divide by n minus 1? So in this case, this is you divide by n minus 1 because they ask us for the sample, which is again 54, which is the sum of the deviation square, divide by n minus 1, which is 6 minus 1 is 5, which is 54 divided by 5, 10.8. The other thing is if on ALEKS they ask you for the variance, this is your variance. Your variance is 10.8. I don't know if they ask you on ALEKS. I don't think they ask you on the final exam. So again, if you were to do the homework and they ask you for variance. And now what is the last step? Well, the last step is we need to take a square root of your variance, or you need to take a square root of the result in step 5, which is square root of 10.8 is 3.286 something, I think. And again, because it's 3.286, we round it to 3.29. Okay, so again, this is your standard deviation, which is reminder the standard deviation is just the average difference among your data from the mean, right? So again, this is the 6 steps to find the standard deviation for the sample data. Okay, if it's for a population data, you have to, at step 5, you have to divide by n, not n minus 1. Okay? So question here, which number 1, 2, 3, and 4? Again, is massive, but we did this last time, and I think is tedious work, but it's not complicated work. So let's take a look at number 5. So looking at this thing here, number 5, they go in and they ask you more about your sample, which is again 6 people from different occupation were interviewed for a survey, and this is their salary. And they ask you what is the mean annual salary, which is again, how do we find the mean? The number is big, but to find the mean, all you do is the same as before, which is you add each of your salary up, each of your data up, divide by the total number of data, which is in this case we have 6 people. Which is again, you add them up and you divide by 6, which is the mean or the average annual salary for this 6 people is 47,750, which is again, you all know how to find your average or how to find the mean. Number 6 and 7, which is again, is basically try to ask you to understand the definition or try to understand the item of the standard deviation, right? So over a 1 month period, stock A have a mean daily closing price of 124.7 and a standard deviation of 12.5. By contrast, stock B have a mean the mean daily closing price of 72, and the standard deviation is 6.1. Which stock have more volatile, right? So how do we know which one is more movement or more volatile? Which is again in this case, everybody see that, remember the standard deviation is the difference, the average difference from the mean. And the biggest the standard deviation meaning is more flexible, right? It's more up, down. So again, because it's stock A, because of stock A have a bigger standard deviation, which is they are more volatile, right? Which is they keep on go up and down in terms of fluctuated, right? Meaning again, it's either because the average is 124, it might go down to 60 and go up to 170. And again, it's basically go up and down a lot in terms of that. That's why the standard deviation is big. The bigger standard deviation, the further away. Reminder your range, right? The bigger the range, the bigger the standard deviation. And again, because your standard deviation is big, the range might be big. That's why it's moving a lot. The smaller standard deviation, your data clutter together a lot. So again, in this case, it's not the mean. The mean is just tell you that's the middle. It's the standard deviation tell you how big of your range is. Okay. Same thing go, looking at this thing here, two class took a statistic test. Both class have the mean score of 73, right? Class A have the standard deviation of 5, and class B have a standard deviation of 10. Discuss the difference between the two class performance. So looking at this thing here, which is again, hopefully you guys see that again, the similar to the previous one, right? The bigger the standard deviation, meaning the range of the grade will be bigger, right? Which is looking at this thing here, do you agree that class A have a smaller standard deviation? So again, the meaning a lot of students will score around the average, right? Around the 73 average. If the standard deviation for class B is big, meaning people kind of spread out, meaning again, the average is 73, but there may be some students score 30, some students score 100, right? The range is big. That's why we have a bigger standard deviation. Again, this two question is basically want you to understand the standard deviation concept in terms of the bigger standard deviation, the spread out the data. The smaller the standard deviation, the closer the data is. Okay. And again, when we went over the standard deviation, I give you two samples for you to calculate, and you can see one of them, the mean is the same, but one of them, the standard deviation was like 3, and the other one, the standard deviation is like 28 because of the spread out of your data, right? But again, those is just a concept. I don't think they ask you for the concept on your final exam, but just to review of what the standard deviation is, right? So let's take a look at this thing here, 8, 9, 10, and 11. They ask you in a normal distribution table, the mean is less than the median is less than the mean and is located on the left of the mean of the graph of the distribution. Is this a true statement? Is this true or false? Reminder, a normal distribution table, right? The normal distribution table, the mean, the median, and the mode is appear at the same location. They meaning they are equal to each other. So this case is false, right? The mean is not less than the median, or the median is not less than the mean, right? For the normal distribution table, ideally your mean, your median, and your mode is at the same location, ideally, and that's what normal distribution is. It's a ideal data, right? If you collect data, your data won't be that ideal, but we want it to be ideal. That's why we say approximately normal. right? Again, that's what we have, which is, again, this is a false. The mean is equal to the median at that same location. In a normal distribution, approximately what percent of the data fall within 1, 2, or 3 standard deviation of the mean in both directions? Reminder, this is your empirical rule, which is you step one step up and one step down, one step to the left, one step to the right, which is, reminder, your empirical rule is the 68, 95, and 99.7. 99.7. I have a wrong typo again. 68% is within 1 standard deviation, right? Within 1 standard deviation. 95% is within 2 standard deviation, and 99.7, not 97.7, guys. Small typo. 99.7%. 99.7% is within 3 standard deviation. When I typed this, I saw it. I'm like, something wrong, but I was running out of time. But again, 99.7, not 97. Okay. That's your empirical rule. And again, now they know they ask you to use this empirical rule to answer. They ask you to try to use this empirical rule to answer the question number 10, right? If an adult male is told that his height is within 2 standard deviation of the mean and of a normal distributed height of all adult male, what can he assume? What can you assume of his height, right? So looking at this thing here,